Okie dokie. Let's give it up to Matt and Tanner, who's explaining us how to earn money by programming.
All right. Thank you, the devil. How are you doing, Tanner?
Hey, dude, I am good. Can I get a quick audio check? Let me know you can hear me.
I can hear you great.
Okay, awesome. Listen, I'm going to disable my push to talk, so I'm going to be always on. Just give me a moment to do that. You talk some introductory gubbins while I'm doing that, mate.
Excellent. Happy to get the gubbins going. We had the talk free feature last week with Scarlett, which was a ton of fun, and it makes it easy. So yeah, today is what the fuck is crypto, and or as the devil put it, what is that? How to make money through programming.
Results and see what it's done. So we're going to choose Python. It's right at the top of my list. I don't know if it is with you or if you need to start typing pi or something in there, but I'm just going to go ahead and click Python. And then create Ripple. And after hopefully a short time, okay, here we go. Do you have my screen okay, Matt?
Yes.
Wicked.
I've got a white screen with anonymous sizzling specific backups.
Yes. Okay, that's great.
Okay.
Sizzling specific backups. So I think this is going to be the unique URL so that everyone can get to this program later to study what we've come up with. So that's
Perfect.
cool. I'm just going to get rid of this. Okay. This will always remains the same. And we always have the name of a variable on the left-hand side of an equals box. Oh, sorry, of an equals sign is defining the, which box we're talking about. Or in fact, declaring that this box exists. Because before we do name equals Tanner, there's no kind of pre-existing box called name. And you can call these absolutely whatever you want, It's completely up to you. So if we replace name with my variable, all we're doing is changing the label on that cardboard box. So this code
function remains the same.
Yeah, exactly. And the pieces of paper we put in the box, as you can see, we're still putting in Tanner and printing that out, and then changing it to Matt and printing that out. So those remain the same as well.
And eventually we have a convention.
Yes,
these are name tags, virtual name tags.
Absolutely.
Okay.
And you come up with your own convention based on the kind of what type of program you're writing. So for example, you might, if you're writing a game, one of the first lines you have might be player score equals 0. And this is a box called player score. And you're going to use that box to keep track of whatever the player's current score is. But it's starting at 0.
Got it.
This fact that we're kind of reusing this same variable, we're going my variable equals Tanner, and then we're going to print that out, and then changing it to Matt, and then printing that out, indicates something else very important, which is that computer programs are linear. Okay? When I hit run and the program starts executing, it starts that execution on the very first line here. And it proceeds in a completely linear fashion, which is why, it's completely deterministic. It's always starting from line 1. So my variable initially is always set to Tanner, which is then we go on to line 2. So when that gets printed out, I'm always first in this list.
Yes.
Only after that print statement that we then change the value to Matt and print it out again. And of course, by then the value is changed. Okay.
Got it. So it's not so much history is written by the winners. It's through the
completely
programmer decides.
Indeed, yeah.
The programmer decides.
Yeah, okay. It's completely linear. And in fact, there's ways to change that. Like we'll see in a minute that we can kind of force it to jump around to other parts of the program. But if you don't do that, then by default, what's going to happen is every line is going to be executed in turn after the previous one. Okay, so let's have a look at another function that's built into Python, which is called input. This lets us allow the user to type something in and capture input from the keyboard. So what we can do now is, instead of setting my variable to be the value,
Ready,
So-
player one.
Okay, cool.
Ah,
So that's good.
beautiful.
Now, I just want to illustrate something. Do you remember how I was saying, whenever we see a single equal sign like that, it means that on the left-hand side of it, that there's a name of one of these boxes that we can put data into.
Okay.
Is the piece of paper that we're going to put in there. Well, this is interesting because suddenly we have a function, okay, on the right-hand side of the sign. That means that that function is actually returning a value, and we're capturing that value into this box that we're choosing to name player name. And again, don't worry too much about function returning values just now, because we're going to get to that in more detail in a sec. That's just an observation at this point. Okay, so to further clarify this idea of functions, let's actually define a function of our own. The ones that we've seen so far, print and input, both built into Python. They're just kind of there without us having explicitly defined. But
And
we
I
can
noticed every
also-
time you start to type something, it'll bring up little helpful prompts, like
Yeah,
autocorrect.
indeed,
But
yeah.
actually useful. Actually useful.
Absolutely, absolutely. But at the same time, it's important to remember, this whole environment here isn't, you can, being in some sort of environment and having all those prompts, it's a really nice development environment. When we talk about Python, it's just a cold hard code.
Got it.
This stuff just goes in a completely plain ASCII text file. There's nothing at all special about the source code files, so they're just literally. So if you really wanted, you could edit them in Notepad. I mean, I wouldn't, but you.
Okay.
So the
Warning
point
to
I'm
the
making is,
unknown. I was just going to say, warning to those like me: go with what shows you what. Don't need to get underneath the hood.
indeed, absolutely. I mean, it's certainly great to have the help, but the point I'm making is just that there's nothing mysterious about source code.
Okay.
Just plain text.
Okay.
There's nothing else kind of hidden in these files. Okay, so we're going to define a little function. At the very start, the purpose of doing these is a little bit tortured, because obviously it's a contrived example. But the idea of creating a function is anytime you have a block of that you want to use more than once, you don't want in the same game. We wouldn't want to do it like that by just repeating it. Okay, I mean, that'll work. I can go ahead and say, whatever, yeah.
Okay.
Colon. Need to put everything in. You see how I've indented everything?
Yes. Does that then that limits that execution command or series of
It's
commands to this definition
exactly.
ask player name? Okay.
We say ask player name. What it's going to do is just perform these commands that are inside that block.
Very good. Little algorithm.
Yeah, precisely. So this little parcel of code that we've made, we always have to end with return. And the precise meaning of like why the word is return will become clear in a moment.
Ah. Yes. Yes.
A call to the function print. So what we need to do is call our function like that. So now see what happens. If I run that, first we're going to get that example, and then I'm going to. But now look what we can do. A button, and where we run. Ask the player's name, which it's doing now. And it's going to ask the player's name one last time.
You know, I am, and I've even talked to people like this at various seminars that I attend. And now I understand what was going on behind the bland face. They were just executing a program.
Awesome.
This is helpful.
All right, awesome. So this is already an example of we're messing with the flow control. Okay, the script is no longer strictly going top to bottom linear. And what I want you to get used to is the idea that behind the scenes, there's like, it's actually called the program counter, but you can think of it as a cursor to where the computer is in terms of executing the program at the moment. Okay.
Okay.
So let me just kind of like manually execute this thing so that we can observe what the program counter is doing. So remember, everything always starts in Python, particularly. Everything's starting at line 1. It's just going to start at the very top of the program. Because this starts def,
yes,
this is going to do is precisely nothing until it gets out of that function definition. And this kind of line of code that it hits, execute that print example. And of course, sure enough, over on the right hand side, the first thing we see is example. When this gets called, ask player. At the moment, my cursor that I'm highlighting things with is just kind of emulating the program counter. So as soon as we get there, program flow actually transfers to line 2.
Ah, yes.
So line 2 then gets executed.
Yes. That's why you need the return.
Yeah, exactly. And this is why it's called return, because it's saying return from whence you came. So
go back.
Program counter just to the next statement following the calling statement. So now we're on line 9.
Beautiful.
Counters going back to 2, 3, 4 to here. Now we're on line 10. And back to 3, 4 here, and there's nothing else to do, so the program's finished.
Got it.
Let's just very quickly do another really contrived example of a function so that I can show you another subtlety of functions. Print line of start. All this is going to do is print a line of start and then return. Okay. So let's just, we'll stick a call to this after our first call to player name.
And what is the semicolon? What does that do?
That's me being very used to other languages. In Python, it does nothing, and it's probably an error. So let's delete that bad.
Very good. Okay.
The thing that I'm amazed I'm not doing is stuff like this, because a lot of languages have this idea of
fancy brackets.
Yeah, indeed, as a way of differentiating where these blocks start and stop. Python's just using white space indeed. So whereas most languages, white space really isn't important, these are indented, what makes them part of this function.
Yes, okay.
Very quick to call you out when you mess that up as well, okay? So I'm sure I'll run into that. But that was very good, thank you. I haven't seen an error over here, and the only reason is because you caught that error before I even made it. So
yeah. Excellent, that's what I'm here for. Yep, no beers for me yet.
Tell me what we expect to see now that we've got this new line.
Well, I would expect for the first ask me my name, I give you my name, and then we're going to see a line of stars, and then it's going to ask me my name again twice. That's my guess.
The point of this contrived Well, hang on. Be something for loop. This line of stars thing, mate.
Okay.
I want to show you another way of messing with the functions. If I do so it's called a for loop.
Okay.
We've got a colon here and we've got the indentation here. So this means we're kind of defining a sub block of code.
Yes.
This 3 times. Let me show you.
Oh, yes.
12. And run it again. We're going to have loads of wows.
Okay.
Let's just demonstrate this whole, just to reinforce this.
That should get us a well and awesome alternating. Yeah.
Remember, all that's happening throughout this program. So now the computer's running it from line 1. This is just a definition, so nothing actually gets output. This is just gets output. This is an actual line of code.
Okay.
Example.
Mm-hmm.
Like the only time we've done this indentation so far is for defining functions. But even though they're indented, because they're not wrapped in a function definition, they're just gonna get executed as it comes to them in the same way as this, the initial print example. So
that's for legibility on your end.
Indeed, yeah, absolutely.
Okay.
For ease of the programmer. So this is going to happen. What's happening at this point is after this line executes, because it's the last line inside the loop it's referring to, that happens. And the actual check that's happening behind the scenes is, has X reached the value of 12 yet?
Oh, okay. That makes sense.
Guess what we're going to see?
Oh, so it'll count 1 through 12. Ah, okay. Okay.
There we go. So, wow, X is 0, awesome. Wow, the current value of X is 1, awesome. And it repeats all the way through. To consider behind the scenes on this very last, actually, let's just put a kind of, prove to ourselves that really this kind of goes around in its little loopy loop and then does pop out the other end. So let me just run it like that. And then we do see at the very end, the loop is hereby ended. So examine what's happening here on the last iteration. So going, wow, the current value of X is 11. I'm looking at this iteration here. Awesome. And then at that point, check happens again. It's going to add 1 to X and say, oh, X is 12. So we're stopping now. We're not going to execute this again. And it's automatically going to jump down to a bit following the loop.
Yes.
So, in day-to-day programming, beyond this very first lesson, you don't actually need to think about where the program counter is. Semantically, that all this stuff's going to get it 12 times, and the value of X we're going to get through those 12 iterations is going to go 0 to 11. now it's useful to be able to keep track of thinking, wow, I'm faced with this whole page full of code. Like what actually happens in what order, you know? So
Yeah.
always think of where's the hardware cursor.
And now it's done. Go get a beer. Yeah.
Making with print line. What's the difference between this function call here and this function call here? Well,
So you're wanting to
aside
know-
from the fact that this is a built-in function and this is what's the
So, I mean, the only difference I can see is the print line of stars goes back to your definition and executes two things before returning.
I'm after the that's very true, but I'm after the difference between these actual calls. So the difference between 11 and 12 is that there's nothing in the brackets here, right?
Correct. Yes.
You remember right from the very start when we did the hello world, I was saying, okay, so we have a function called print, and it's
Yes. So function argument.
print line of it hasn't needed an argument because all we've wanted to do is just print this line of stars, right?
Yes.
But if we want to of stars, we were calling it lines of stars. You can see where I'm going with this. And then
Yes,
we wanted to
yes.
be able to pass a number in there. Argument. So we'd like to be able to do that and then have it print 3 lines of stars with a single function call, for example.
Okay.
So let me just show you how. In the function definition, you'll see again the brackets are empty. So here in the definition of this function, it's saying, look, I'm defining a function, just one that you call, you know, an argument. It doesn't accept any arguments. So you just call it like that. But in here, we can means that whatever the calling code here on line 12, brackets, available code block inside print line of stars with
Got
this. So now check this out, okay? Let's hardwire it first of all. Let's just make it so that we're getting a loop of stars. So we're going to do the old X range naught. Let's just go 12 just to start with. Colon, because it's going to be a sub block, and then of course we need to indent this to indicate that this is the bit that's going to
Yes.
loop. All right, let me just do
Don't
that.
indent return. Very good.
I don't indent return because that's outside the loop. We want this to
Yes,
loop, this
yes.
to loop, this to, and after that's done, then we want to
Then gotta
return back to
return.
the calling code.
Perfect.
All right, so we can see that's worked insofar as, you know, as expected, we got 12 lines of stars. But unsurprisingly, we can just take this variable name and pop it in place of that 12. Now, every time we call this, it's going to print the number of lines we've actually asked for.
Ooh.
Let's try something like we don't need this anymore. So what do we expect to see here?
So I would expect to see a label example 1. We see 3 lines of stars. Label example 2, 12 lines.
Okay,
And
I'm
label
convinced.
example 3,
Let's try
1
it.
line.
Please.
Interesting.
It's saving. There we go. We got there in the end. No?
Yes.
Yeah, eventually it did. Okay, cool.
Okay. Very
It's maybe not.
interesting.
Yeah, let's clear this thing and go again. Yeah. Okay, super.
Oh, got it. Very nice.
So, belaboring the point, but just to again drill home this point of the fact that there's this program counter. Execution starts here. Example 1. call this function, execution jumps up to here with num stars set to 3. So it's going to do this once, twice, return,
Yes.
and then we return. It's going to print example 2 in this function with an argument of 12. We find ourselves back up here. Num stars now equal to 12, so it loops 1, 2, 3, 4, blah, blah, blah. Well, actually 0, blah, 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 11, and returns. Are you with me so far?
I am. My only question is, why do you start with 0?
This is it's I'm not quite going to call it a core truth because it's not so much a tenet of programming as it is a convention. The simplest answer is that it's a lot easier in hardware to think of things as starting at an index of 0, kind of an offset of 0 from the start, if you like. And that kind of permeates its way through to software. So while I'm not going to call it a core truth of programming, in actual fact, just by convention, you'll find that that's the case in the vast majority of languages. Counting starts from kind of range of things. Like if you have a range of 10 things, that then usually going to 0 to 9. But the way to wrap your head around it is think of it as an offset from the start position. Is that the kind of sanest way to grasp it, I think?
I like that.
Well, literally about to say,
Asking for
yeah, I'm watching the. You've completely spoiled my say. Literally about to say was that we're now very close to stuff that we already have to some sort of, and actually build a deeper program than you might expect us to be able to at this point. So if Deceivable has a musical number in store, it might be a nice time for a refreshment break, a quick musical interlude, and we'll pick up after a word from our sponsors.
Right on.
And our sponsors are Wash My Axle, SAP.
Sometimes the devil knows what he's talking about and the rest of us don't. Or at least I don't. Yeah. This is the occult.
Up, guys.
There was Blackened, a remarkably competent recording considering it's issued by Metallica in 2020 of all things.
So this is a new version. I listened to this when I was 17 years old back in the day.
Oh,
So,
yeah,
wow.
I mean,
well done, Metallica.
I was a little younger, but yeah, not too much younger, and listening in the day myself. I'm not too sure about that dodgy acoustic guitar in the left channel, but apart from that, I was liking that.
That would have been Kirk Hammett. He's losing a step. All right.
I turned coffee into coke.
Whoa,
Let's see
I
what
just
happens
came
when we
back from a cigarette.
Right, you
I
haven't
want to
missed
say,
anything.
don't you think that the singer from Metallica looks more and more like the lion from Dorothy?
Yes, actually. Yes, I know exactly what you're talking about.
Yeah,
Wow.
it's the meme. It's the meme. But
is.
if you look at the
I didn't
meme,
know
it's
that.
like, damn, all his face reconstruction he paid for was like to be a lion.
Exactly. It all comes back to the Oz, the Wizard of Oz. And we're seeing the code. And Tanner is our Wizard of Oz, I think.
All I'm thinking of is Snoop Lion now, to be honest.
Snoop Lion. Haven't seen that meme, but does conjure an
No,
image.
Snoop Dogg there changed his name to Snoop Lion and released an album.
Oh, I did not know that.
Ago.
Okay.
Yeah,
What? He's doing the print thing or what?
Well, it seemed briefly like a Prince thing, but no, I think he just got in touch with his roots and named a Snoop Lion and released a regular.
I mean, I posted before about porn, but Snoop Dogg, the last thing I saw was a video of, you know what I mean.
Okay.
So taking out.
Okay, back
Yeah.
to programming. Yeah.
Yeah, and I'm subtracting all of this bullshit and the musical interlude, the advertised 60 minutes in which I will teach you computer programming.
Yes.
We're still well on target. On target. It's absolutely fine.
Kicking ass. Good.
So I think you're comfortable with everything on my screen at the moment, Matt.
I am.
So we've already seen that some functions are built into Python, print and input, and some we can also define our own functions. There's a third class of function which is available via kind of extensions to the core language. These are called libraries. So access to a lot of rich functionality that's built into the core language, but it's kind of available to us from any time that we're using the language. We just have to specify that we want to use it. So we do this is to import. The name of the thing that I'm importing is random. So the import statements always go at the start of your program. Anything that's kind of not part of the core language, but it's a library and you want to pull it in, this is always going to go at the top.
Okay.
No, don't show me an advert. Thank you. What's it called? Ripple. Just while I think of it, I'm going to show you comments. Any line that starts with a hash is just a comment. It's going to be completely ignored by the computer, just for our own human readability sake.
Hashtag comments.
A single hashtag, and then the rest of the line is a comment. So we can put whatever we want there. So we can use this to leave ourselves little notes. So kind of already our typical program has kind of 3 sections. Let's just label them for our own sanity.
You have the hashtag, which is your comments. And you can literally, these are notes to yourself.
Exactly.
Okay.
So I'm going to one label right at the top saying that, hey, just below this is where we're going to put our library imports. Tell Python which non-core stuff we want. And then my function definition's all here. It's kind of the entry point, if you like, application. Execution starts here because this is the first line of code that we come across that isn't just indicating something to the computer or defining functions that we're going to use later. So we can kind of think of this as our entry point. Okay. So anyway, the whole point of doing random was so that I can access some extra aren't part of the core language available to us in this language. See what I mean? Let's make a variable called dice roll, and we're going to give to dice roll is whatever value we get back. Now, just stop a moment. What's up?
I was just about to ask. Yes, I would have been.
To break that down, if
Yes. I am.
What's happening when we do this random dot? This is kind of an object specifier. So this is saying a function called randrange, which exists within an object called random. Now, I'm out of my way to define the term at the moment. I just want you to just realize that it means a container of functions. And we just do random dot. The function we want to call is part of this functions that's called random. And some hierarchy.
Okay.
Have, for example, this is bullshit code, it doesn't exist, but you might have a package called whatever, and inside that there's another package called gubbins. that, there's another package called blah, and inside that there's a function. Just do whatever, you know. I wanted to kind of drill down through this hierarchy and call that function. You'd end up with this big series of dots. Now I don't want you to worry about any of that. Just do this and think, okay, it's a function call, and I can see that this function lives inside a package called random. Simple as that.
Okay.
Guess what this function does? The clue is that it's in a package called random, and
Yes.
rand range, and we're passing it an argument called 6. What do you think it's going to do?
I think you've just made it a 6-sided dice or die.
Okay, let's see if you're right. I may have accidentally made it a 7-sided dice. I'm honestly not sure. Let's find out. The dice roll was 2. Dice roll was 3.
Fine.
Run it. It's giving me a different number. Pop quiz. How would I? Let's say I wanted to get a dozen dice rolls, one after the other, all just shown at once without me having to click play 12 times. What would I do?
So I know if it were a you know, either a for loop or a command, we could just put the brackets, the number.
I mean, that sounded good. The for loop. So 4x in range, 0 to 12. And then because these are now part of the bit we want to repeat, we just need to tab them in one so that they're part of this block.
Yeah.
There's one small problem.
0.
So it's not a 7-sided dice, it's a 6-sided dice. It's just they're numbered 0 to 5.
Yes. Yes.
So
does our starting point need to be 1 then?
We know that this function's always going to give us a number 0 to 5 if we call it round range 6. If only there was some simple fix we could do to shift that number so that instead of being 0 to 5, it's 1 to 6.
Yeah.
So let's say it gives 0. What do we need to do to the number 0 in order to get it into the range that we want in order to make it
the number 0, you have to add 1. It would be +1.
Like, let's say it's spat out
minus
5.
+5.
We want that to map to a 6. So again, it's add 1.
Yes.
So this seems like it's going to work. We just need to add 1. All right.
But where?
Remember, anything on the right-hand side of an equal sign is defining the value of the bit of paper that's going to go in the box that the left-hand side refers to. So
yes, that's
we can
right.
simply go dice roll +1. This is quite deep. This single line here equals dice roll +1. What that's saying is hand side of the equal sign. Value that we're going to get and write on a piece of paper is whatever the current value of dice roll is. So
+1.
Let's say this executes and rand range spits out 2. First of all,
now it's going to be 3.
2 plus 1 is 3.
Yep.
That's what gets stored in the box marked dice roll. See, first of all,
beautiful
value that we get this function into dice roll. Using that self-same value to calculate an modified value for dice roll, and then we're going to print that out at the end.
Okay.
Let's see if it works.
So that's not considered a self-referencing loop because it's on subsequent lines.
Precisely. Yeah. Well, yeah. It's not. Yeah. And actually, even if you examine it like within the context of the line, like hey, going to the same thing twice. Well, remember, anytime we've got an equal sign, the thing on the right is calculated first, and then stored. Box the left refers to. So because of this, it's completely deterministic. We know what's going to happen, and the computer doesn't get confused.
Perfect.
Let's run it, and hopefully, yeah, okay, we see a 6.
Yep, and we see no zeros.
And we see no zeros. Let's just run it a couple more times to convince us. So, zeros. Okay, that's cool. That's cool.
Beautiful.
I want to show you. I'm going to write dual program that has some sort of point besides just.
Okay, I'm getting ready.
So here, let's just remove this loop. We have to move it, tab it. It's top level code again because it's not part of a block now. Show you a way of messing with the flow control. So we've already seen for loops. It from being a strictly linear top to bottom flow, introducing these little loops. Function calls, which make our program counter zip off and do something else completely until we hit a return statement and come back. The third form control is conditionals. This is where we can introduce we want to, show a special message like, woo, you hit the jackpot type thing. Pretty easy to do. If, and then we're going to have something in brackets. I'm just going to come back to the and then we're going to have a colon. And then, of course, the colon defines a new, it means we're talking about a sub block. So I'm going to go. And what goes in the brackets is the condition that we want to evaluate. So all we want to do is show this message if dice roll is equal to 6. Now, hang on a minute. All this shit.
Right. I saw the double equal.
It did.
What is this?
And I could feel from here the cogs turning.
Yes.
A single equal sign. This is one of these things that's not quite kind of a universal core truth in the way that if statements and for loops and functions are. It's more just a convention that you're probably going to see in practically every computer language. A single equals is called the assignment operator. And that's used when we're doing this whole thing of whatever's on the right-hand side, we're going to calculate it, fit in the box indicated by the left-hand side, okay? Assignment operator. But when we see a double equals, then that means is equal to.
Okay. Got it.
Just kind of, the language could have been designed so that we could say if dice roll equals 6, but it's not. In order to say.
So you need double equal if you mean equals.
If operator for equality.
So
unlike the case of if we just examine this line, we know that because the single equals, the thing on the left is always going to get updated. We don't want to update. We want it to change at all. We just want to compare it to something. Whereas this is the assignment operator, this is a comparison.
And it changes it. Very good.
The assignment operator changes it. Comparison operator doesn't change the value of dice roll.
So I think of it as like a little binoculars, right? It's observing. Thank you. I try.
Very, very good. Okay, so, just to prove the point, I'm going to put down here. Just to prove that whatever it is, it doesn't actually get changed by.
Yep.
This is the first line of actual code that isn't just defining a function or importing something. This gets run. This gets run. So then we see that statement, the dice roll was 4. Then this, if condition checked. If that condition is true, is equal to 6, then will get executed. Otherwise, the entire block gets skipped. That's not just one line. We could have, because it's a sub block, we can have as many as we want in there.
Yes.
Condition's not true, block will automatically get skipped, and the program counter will be on line 17, 18, 19, it'll skip straight to 22. Of course, is what we see for because that condition never triggers. it a couple of times. Oh, look at that. I got lucky.
They're right on the next. You're feeling it.
I'm in sync with the machine. Are
Man
you
and
comfortable with
machine
what you're seeing
melded.
here? Matt, are you comfortable with everything that you're seeing here so far?
I am. Sorry, I didn't realize that was an input required. Yes.
No worries. Yes, that was a prompt.
Yes.
All right, cool. So I think, and I realize I'm maybe going too fast for some. And if that's the case, like, honestly, I hope there's going to be a capture of this. Take your time. Do go back. Do ask me about things that don't make sense. I'm obviously not monitoring Discord chat right now in real time, but
Yes.
if you have any queries, please get back to me.
I was going to say, I'm not monitoring either because I am focusing. This is good stuff. Very good stuff.
Well, there's just one more bit of flow control that I want to show you, and then we're going to write a little program. So in the same way as input gives us something we're able to put into a box, because of course that's the assignment operator right there.
Yes.
Everything on the right of it is going into a box. So obviously there's a way to get functions to not just return, but to return a value. So ideally we want to be able to say something like, choice equals get player choice. And be able to say, to then use that later in our program, like something like that. That's what we want to be able to do.
Very good.
And all we need to do, in fact, to return a value from our function, in this case, player choice is the value. We just modify the return statement. So instead of just return whatever the value is that we want to return. And that instantly makes it so that we can, us just doing that, if I take that away, sure if it'll bitch about this line when I try and run it. It might just, it did just actually run. Actual fact, choice is never gonna, let me put it in. Yeah. So if I put an R in.
It ran it, the flow went to print, did player chose, and then went to choice, which is nothing.
Well, I did type R, but of course, the problem is,
get player choice.
I put something in this box, nothing went in the box because this just has a naked return. It's not returning a value. What we need is just do that. And then now I should be able to R. The player chose R.
Excellent.
All right, cool. Apart from this returning a value from a function, this isn't anything we haven't seen before. So once again, in terms of the program counter, here's the entry point. Remember assignment operator, so whatever's on the right choices gets spat out of this get player choice function, and because of that equals gets put in this box. So then flow control proceeds to line 12. And many languages would refuse to run this. They would say, hey, you're calling a function that the computer can tell it doesn't return anything because we've just written return there. What happened? Yeah. I think it's auto saving or whatever. Give it a second. That's quite annoying. Failed to connect. Can you still hear me?
Yes.
Oh, we're back.
Very well.
It's gone again. And we're back. Okay. So many languages would completely refuse to run or compile that. Python, in some ways, it's good that it gives us like this default value of none, but in other ways, I mean, it's kind of annoying. The fact that we're using the assignment operator here means we're clearly expecting to capture some sane value from get player choice, and that naked return, we're never going to capture any sane. So let's refix it. All this was a preamble of the new bit of flow control that I want to show you.
Yes.
What's the looping structure that we've already examined? The for loop, right?
Yes.
So as we've seen, the for loop is absolutely ideal when we know in advance how many iterations we want to make. Like the for loop, let's just say, I've got this block of code. I want you to repeat it 12 times, okay? This is a beer. This is a Hobgoblin Ruby from Witchwood Brewery. .5%. Okay, so if we know in advance, well, I mean, I say in advance, if we know by the time we get to that line of code how many iterations, then a for loop's brilliant. However, what do we do if we don't actually know how many times we're going to need to run something? This is a perfect opportunity for a while loop. And the use case here is there's no guarantee the stupid bloody human has actually typed one of the valid letters.
Yes.
What we want to do is we
This
want
is
to
true.
check it and repeat until, like, they type something that's non, just kind of jump straight back to, no, I'm not accepting it. Please give me a proper one. So, and I'll show you how we do this. First of all, you can think of this as a flag. It's only going to ever have the value of 0 or 1, and we'll call it player has made same choice. And we're going to start with this variable set to 0. Okay, this is really going to be a good test for your program counter tracing skills, tracking this through. So what we're going to do, while has made same choice is equal to 0, we're going to ask them to make their choice. We're going to accept their choice. And now, still within the loop, still within the looping block, we're going to do an if check. We're going to say if player choice is equal to R, or, because we can do that, we can do these compound Boolean expressions when it comes to evaluating conditionals. So we can say if player choice was an R, or if player choice was a P, or if player choice was an S, then we set player has made same choice to 1. And I'm just going to, our program counter is going to jump up here. Right. We're going to set a variable. This is off. You can think of this as a flag. Okay. And in actual fact, instead of using 0 and 1, I can even set it to false, and change the 1 to a true.
Okay.
And this really just indicates that, hey, we're only using this for, it's like a Boolean. It can only have one of 2 values. You know, if we use 0, 1, it's a little bit ambiguous because, oh, what happens if it's 2? Whereas this way, it can only ever be true or false. So we're just using a Boolean here. So first of all, we're setting our flag to false. We're going into this while loop. This does, the first time we come across it, first of all, it will check the validity of this condition inside the brackets. And this is, you know, a lot like, had an if statement there, you would completely understand it, right? If that flag is false. Well, with a while statement, all that's happening is it's a looping structure, but condition here is getting evaluated exactly as though it was a condition in an if statement. The first time we go through, player has made same choice equals false. This statement is true because the flag is false. So
yes,
we go in and execute. Please make your choice.
Okay.
We're going to print it out. We're going to get their input. Now, just for the sake of argument, imagine the input was Z. They typed a Z. Okay. Now we have an if statement here, which isn't going to trigger because the statement is if player choice was R, or it was P, or it was S, but ours is a Z. So this line is going to be skipped. And now, of course, notice because this line is outdented, it means we've come to the end of this indented block. And because it's a while loop, it's going to automatically loop back to here and perform that check again. Anytime it gets to the end of this little block inside the while loop, it's going to go back, perform that check again, perform that check again. And as long as that check remains true, it will keep executing. So once more, entry point here, program counter jumps up to here, set the flag to false. Is the flag false? Yes, it is. So we're gonna get their input. They typed a Z, so this line is never gonna be triggered, and we're at the end of the indented block, so it's gonna loop back here. Is the flag false? Yes. So we're going to repeat. Choice. Get the choice. Oh, okay. So this isn't getting executed. With the end of the while loop. Loop back to here. Is the flag false? Yes. Make your choice. This time they enter an R. Finally, okay? Now they've entered an R. We perform this condition check. Player choice equals R. Oh, yeah, it was. So this time only, this line's going to get executed. And all this block under the if statement is doing is setting our flag to true. Okay?
Yes.
So that's fine. We've done that. But again, we've reached the end of the block underneath the while. So it's going to jump back. And once more, it's going to condition. It's going to check this condition. Is the flag false? Well, no. We just set it true, which means that this time the condition check fails and it knows that it has to jump over to the next statement after the entire while loop, which in this case is a return, and we return back to the calling code. So
okay,
what we have with this whole flag and then a while loop, big on keeping track of the program counter when you're just learning, because you're jumping here. Now it's checking this. The current value of this is false, and and you have to mentally kind of think, oh, if we've jumped in here, if this is now true, it's going to jump back here. It's going to compare it one last time, and that last time the condition is going to fail because we've set the flag. It's going to jump over here.
So 2 questions then. On return, you have player choice. Why is it not get player choice or choice? Just
Simply
14, excuse me.
Sure, absolutely. Well, that's simply because when I return something,
variable there.
I have to give the
Yes.
exactly. I have to give the name of the box. It's completely arbitrary. See here on line 10, that's the first time I actually use this term. So yeah, of course, I could just use a shorthand, just change the choice. But of course, now you see we have red lines on there. We've referred to it. So the only rule is you have to be consistent. The first time you use the box, that's you putting the label on the box. But thereafter, you've always got to refer to it as the same thing. If I'd created multiple variables inside this function, then that's the point of having to specify which one I want to return from the function.
Makes sense.
Cool, man. So this last chunk in particular, if you're watching on playback, if you don't grok what I'm saying and you don't understand the flow control, particularly of the way this flag starts down and periodically gets checked, and if the flag's still down, we're going to keep on going, we're going to keep on going. But as soon as the flag goes up, next time the check is done, then we're skipping past all of this. If you don't get that, then just go back, watch the last 10, 15 minutes slowly. If you still don't understand it, then ask me. But from where we are now,
I hope this on the record because we had some troubles. But anyway, I hope it's fine.
it's no problem. I mean, if needed, we can repeat the whole sesh. It's no worries. But yeah, I hope it's captured okay.
No, it's because all the video and the audio stuff, and the problem is with Discord, they put you on hold if you're not attending all the time. That's the problem.
Interesting.
Well, what I'd like to do, with your permission, Matt, is
Yes.
That's kind of it for the knowledge dump for this evening.
Okay.
What I'd like to do is have another musical interlude. But then I'm going to use all of the things that we've looked at this evening and tie them together and actually flesh out this rock, paper, scissors game that we already have the player choice function for. It'll only take a few minutes. We'll end up with a complete program that demonstrates everything that we've looked at. You'll be able to go away and study, as well as use for your homework, which will be issued soon.
Very good.
All right.
Loving this.
So back to the DJ for a quick tune before the final.
Yeah. Then I have to say it's it took me back to my school education and all the stuff with all this. When I was in school, I had BASIC and Pascal and all this stuff, and the problem actually was back then that I knew more than the teacher. And the fucking thing was, I didn't learn after that because I was always advancing, and then I stopped, and that was I don't know.
Yeah, so you never had
My business stuff went well, but like I said, I'm telling you, my programming stuff stopped actually.
And yeah, I mean, all of these things that we're looking at, this will be, I'm sure, familiar to you from Pascal and Basic, sticking to the universal truths.
I
And the
know.
universal truths are variable,
It reminds me a lot of things, but like I said, it's like always when I'm stuck at National Instruments, LabVIEW stuff, and programming this and that. Okay, that's just modules, no? But always and he's programming this and that, and I was like, fuck, why did I stop?
Honestly, it's absolutely never too late. And I know that's a cliche, but I've taught people to hero level from zero, where they haven't started until fairly well in their 50s. I mean, it's mostly just having directed learning. Like if you're into self-study, then often all you need is kind of a poke in the right direction.
There you go.
Yeah. Let's have some music and we'll get back into it.
I switch from free microphone to push to talk because it's sometimes embarrassing when you sing along or something like that. So Tanner, you got any music wishes or something?
Oh,
Loud belch.
something we need something soaring and epic and inspirational. We need musical mind food, but I'll leave that choice in your hands.
Soaring, epic. There's a band out of, I want to say, the Netherlands called Volbeat, and I think every single song they've ever written is soaring.
Okay, epic. Let's have one.
Hey Matt, just push play blah blah blah, and I released.
We'll be back.
That would be a null return. I have to press play.
Minus play, distance, artist, distance, song title.
Don't know what to do.
Minus play.
Minus play. Where should I see
space?
Minus play?
Type minus play. Just type any way you want it. Any way you want it. Any way you like it. Minus play. Distance, artist, distance, song title. I don't see groove anymore, so it might be good. So it means not restricted. Okay, meanwhile, Tanner, you're on?
Yep.
Okay. Okay, you're the closest to Great Britain. And I just read Lemmy talking means the guy from Motorhead.
Oh.
So why is he called Lemmy?
Why was he called
Lemmy Kilmister?
Yeah, why was he called Lemmy? You know the answer?
Rest in peace.
Okay, you can hear, because I have a mechanical keyboard, so you know that I'm not Googling this. I want to say that he was christened Adrian or something like that, was he?
Nah, that doesn't matter.
And
raw, cold.
Got to the rest of the origin.
Very
You
cold.
can play this music so I can go and have a pee or what?
Okay. Okay. We're gonna play Motorhead. Then
My dad.
Yep.
All right, lovely. I'll be back in a sec. Cheers, ladies and gents. Oh yeah, I need to kill on to. So anytime we have an else, we know that always, if this doesn't execute, this is going to, and vice versa.
Okay.
These cannot both execute, but one of them always will. So either this condition is true, which means they did choose R or PRS, in which case this is going to execute. But if this condition is false, our program counter is going to skip straight to line 14 and execute the else. So what we expect to see here is, well, I mean, much as it says, and you know, a large part of code is it's kind of self-documenting. You just need to learn how to read it and follow the flow, and you can see exactly what's going to happen. But let's just run it and make sure what we think will happen will happen. Z, lowercase r, uppercase r. Okay, cool. All right, so that's what I wanted to show you, just the whole else thing. Happy?
Very.
All right, so with that in mind, let's write a stupid little game. Okay. Tell you what, let's, and I'm going to speed up a little bit. I'm going to narrate what I'm doing rather than kind of examine the principles behind everything that I'm doing, because everything from here to the end of the session, you've already seen the basics behind it. I'm going to declare a variable compute choice num, and I'm going to set it to a random number between 0 and 2. I'm going to convert that actually to a letter so that we can, just for sanity's sake. So I'm going to go yeah. So I'm going to have two variables for tracking the computer's choice of rock paper scissors. I'm going to have a numeric version, computer choice num, which is the number between 0 and 2, and then I'm going to set the value of a text variable that I'm just calling computer choice without the num to a letter based on what it was. So it's just going to look like, you know, if we rolled a 0, we're going to set this variable to be R. If we rolled a 1, set it to be P. If we rolled a 2, set it to be S. So by the time this block executes, we'll have rolled a dice. Depending on the result of the dice, we'll have set computer choice to either the letter R or P or S. And then we'll ask for we're not going to show the user what the computer chose yet, because otherwise it's not very competitive. But let's, hey, look, we've already written a function to do exactly the thing that we need. This function, as we know, is going to insist that the user types either R or P or S and won't return until they have made a sane choice. But the function does return that value to us, so we can capture it and put it in a variable, which now I think we'll call player choice, because, okay, so now we have a player choice with a letter in it and a computer choice with a letter in it. So all we need to do is work out who won, right? Because they've both chosen R or PRS. All right, so of course, there's a gazillion ways you can write anything. I'm just thinking about the most concise way and the most succinct way. And very often, like, you know, you'll write a first revision of something, and you'll end up with a whole load of code, and you realize that, hey, you can actually express it a lot more concisely.
Because really, if the one is R and the other is P, then you have to return a winner, right?
Yeah. Okay. I mean, that's all right. Okay, that's good. That's good. Oh, so let's have a variable called winner. All right.
Okay.
Okay, I know. Let's do this. We'll set its value so that it's initially the computer, but then we're going to have a if, you know, player wins condition. Then we'll set winner to the player, or you. We'll just you. And okay, so, and I think, all right, yeah, okay, I know what we're doing. So we just need to examine each possible win condition and check for it.
Yes.
So if the player choice is R, what does rock beat?
Rock beats scissors.
Scissors. It blunts scissors. Okay. So if the player choice was R and the computer choice is scissors, then the player, oops, that's again this double and. In Python, you use like actual words and or. In other languages, you use double ampersand for and double pipe for or. That was just I don't ever use Python, so I'm really rusty. Okay, so initially this value is the computer, but if the player picked an R, oops, that should be an and the computer picked an S, then it means the player won. All right, so there's another 2 win conditions. I need a colon on the back of there. So there'll be 1 win condition for each choice that the player makes, right?
Yes, correct. I see what you're saying.
Okay, and then we just need to
And
figure
that's
out
why you defaulted to the computer.
exactly, yeah. So that then I just need to check the player's win conditions, and just with this little block, we figured out who won the entire game. I just need to fill in the correct values here. So if the player choice was paper, that beats paper wraps rock.
Rock.
And if the player choice was scissors, scissors cuts paper. All right. So with this little bit of logic, by the time
we do have something if they both choose R though, or S.
Oh shit! What happens there? Is it a draw technically?
It is. Yes, it is a draw.
Okay. Well, no worries. If let's do if player choice. Hang on. Let's do this last. If player choice equals computer choice.
Beautiful.
Nobody won.
Beautiful.
Okay. All right. Cool. So now we've got the logic. We just need the presentation. So we just need to tell them about it. Let's just give them a summary of what they chose, what the computer chose, and who won. So you chose, yeah, okay, polka, player choice. This space here, so this, we're already getting into stylistic things, which means I must have taught you all the fundamentals of programming, because now we're talking about bullshit. But you'll notice that what I generally do is I don't leave a space between the function name and the opening bracket.
Yes.
The function call. But if it's conditional, like a while or an if, then I do tend to do that. It's just a style thing. It doesn't really matter. You'll get extra points if you adopt the same convention in your homework, however. So after we say what they chose, we'll put the computer chose computer choice, and then we'll put a message there so that it'll either say the computer won, you won, or nobody won.
Perfect.
Okay.
Got it.
All right. I'm just going to zoom out a little bit. Can we get all this on one page? Programs are a lot less intimidating when you can get them all on one page. Okay, there, is that too small to see? You can probably see me on full screen.
No.
All right, so just before we run it, let's just quickly familiarize ourselves with the overall anatomy of our complete program. We start with the library imports. The only thing that we need that isn't part of core Python is random, so that we have that cool ability to roll dice of any number of sides. Then we have function definitions. Like in practice, we might break this program down into more functions. I quite like it the way it is. It's fine. And then we have the entry point, and this is a very linear flow. It's quite easy to see what's going on here, I think. But basically, the computer chooses, the player chooses. Let's add some more comments. Computer chooses. Player chooses. Not spell. Then we figure out the winner. And then we display the results. All right. Do you think it's going to work, Matt?
Yes.
All right, let's hit it. Okay, it at least compiled, so that's a good sign. I will choose what my choice is: rock, paper, scissors. I'll choose no, I'll choose F for fish. Okay, yep, that's good. The error handling works. I'll go R. The computer chose P. The computer won. Paper wraps rock. Yep. Okay. Yeah. I like it. Let's try again. P. Nobody won because we both chose P. Yeah, that's true.
Yeah.
Let's go again. R. I chose rock. The computer chose scissors.
Rock smashes scissors.
Have we seen one where the computer wins yet? I just want to see that.
Me. Sorry to interrupt.
Oh, nice.
The recording is not really working well. So if
Fine, I don't mind.
get to some finish and yeah, sure. And post it to Euros, yeah. And maybe we continue next week with a better solution for streaming.
Yeah, well, I don't like to repeat, but we'll have to start again because I do want this to be a kind of good library archive.
Yeah, sure.
If you don't mind, I'm just going to continue.
Yeah,
because I just want to continue.
Yep.
All right, cool.
That's fair.
So this is pretty awesome, but it's a bit annoying to keep rerunning it. So the last thing I wanted to do is just make it so. Let's make it best of 5. Oh no, well let's make it first to 5. How's that sound?
First. Okay.
So all we kind of need to do really is take what we've got and wrap it into, unsurprisingly, some sort of loop. We want to repeat all this bit while keeping track of score. So let's make a couple of new variables. Let's have player score, that's going to start at 0. We're going to have computer score, that's going to start at 0. And we're going to use a while loop to say while nobody's got to 5 yet. So while player score is less than 5 and computer score is less than 5, we're going to repeat all of that stuff. Let's change this message so that instead of saying just 1, it says 1 the round. Let's build a new section in here to award score. So if winner equals U, player score equals player score plus 1. If winner equals the computer, don't forget your colons, then instead we're going to update the computer's score. Okay, I think that's all we need to do. So if you think about it from entry point, we're setting the scores to 0. We're checking if this condition is true. Is player score less than 5 and computer score is less than 5? If so, play a round. The computer chooses, the player chooses, we figure out who won. The new bit is that if we did have a winner, if it was you, the player score is increased by 1.
Plus
if it was
1.
Computer,
okay.
The computer score was increased by 1. And then we display the results for the round. But then at the very end, outside this loop, you notice I'm outdented all the way back to the left-hand margin. So this is after the loop. We can just show a final who won message. And all we need to do for that is if player score is bigger than computer score, print congratulations message. And we're going to use else, so that if player score wasn't bigger than the computer score, We'll show a fail message. Okay. Let's
You
try
are
it.
defeated.
Oops. Yeah, right. Whoops. Okay. Oh. Ah, there's. Yeah, I want to see the scores as we go. Let's at the end of each round, let's show the current scores. No, at the beginning of the round, let's show the current scores. Why not? Whoops. Manny, shush. I'll get you dinner in a sec. Good lad. All right, that should do it. Let's go. Nice. I chose R. The computer chose R. Nobody won. The score didn't change. Good. I'll choose R. The computer chose S.
Yep,
Rock,
your score is 1.
my score's 1. I'm just going to keep choosing Rock. P beat R. The computer won. I won. 2-all. 3-2 to the computer. 3-3.
Oh, tied.
4-3 to me.
Oh,
Tense.
ah,
Tense. Oh!
ah.
Constant draws. It's like he's reading my mind. Okay, I'm gonna have to choose something else. This is getting spooky. Yes, I am the world
You
champion
won.
of Rochambeau.
Shoved its little face in the dirt. Love it.
All right. Now, I'm going to leave this program here and not make it more complicated than that. It illustrates everything that we've talked about. And I said at the start we'd be talking in terms of core truths, and those core truths are functions. Okay? Whether they're built-in ones like print and like input,
Yep.
whether they're ones that we've defined ourselves like get player choice, whether they're functions that return something so that when we call the function we can capture the return value and put it into a variable, or whether they don't, like print, for example. I mean, there's no point us doing, you know, whatever equals print, because print doesn't return anything. It just prints stuff out. Whether they accept arguments or not, like print accepts an argument. I know our show n lines of stars did accept an argument, but our get player choice doesn't accept an argument. Input doesn't accept an argument in this use case. So functions in all their glory. That's one of the universal truths. Variables is the second of the universal truths. In any language, you're going to be able to define functions. They're going to optionally accept arguments. They're going to optionally return values. In any language, you're going to have variables. You're going to be able to label a box and put data in it and manipulate that data by the name of the box. And the third universal truth that we've looked at tonight is really the general principle of flow control. The fact that there's always, you can think of it as a cursor, like where are we now? And everything's going to start at the top and step through in a linear fashion until the programmer does something that fucks with that linear order. Whether it's a while loop, a for loop, or a conditional. So that's everything that we've seen tonight. If you've never programmed before, it is quite a bit to take in. If you have programming experience, it was probably a bit boring, but this is really, I'm just teaching you the vocabulary and enough to kind of make sense of what's to come.
Yeah, so function, variable, function, variable,
and flow control. Exactly, yeah. Those are
Okay.
those are really the three things. And honestly, you can solve any computational problem with just those concepts. Every language has its own specific niceties, none of which we've been using very deliberately, and we probably won't going forward, because I want to keep everything as general as possible. But the art of programming is in
can you
doing.
scroll all the way up so that the bottom of the program shows? Good. Other way. Yep, there we go.
I'm trying to capture this because it's like.
Yep, I'm just doing a screenshot.
You don't need a screenshot. It's here.
Oh, I don't need it. Okay. We just go to the to the web address. Perfect. We've got the link.
You've got the link. I've just pasted
I'm
it in
practically gas powered. So good.
Okay,
I'm
no,
glad
that's
we
not
have
a problem.
my bidders here.
All right, so the art of programming isn't in the listening, it's in the doing, which means there is homework. And I heartily encourage you to do it. There's a choice of 2 homeworks. Option A is for the less comfortable and the less confident. It's still quite challenging, and I'll, you know, if you've never done this stuff before, and I'm happy to provide assistance. So homework option A, I want the 99 bottles of beer program. Okay, so I want a program that's going to print out 99 bottles of beer, 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, 98 bottles of beer on the wall. And get all the way down to there are no bottles of beer left. So this should be done in Python. It should be done here in Repl. You don't even need to sign up for this tool that I've been using, repl.it. You just literally go to homepage and click Start Coding, choose Python in the drop down, and there you are. You're good to go. So that's option A, 99 bottles of beer. Option B, this is for the more confident, is to re-implement our game of Rochambeau in the language of your choice. And that's it, man.
Okay. Well, I will choose option A because I have never coded before in my life.
It's perfect. It's perfect. It's challenging, but it's not at all impossible. You have all the tools here that you need from this example program to be able to figure it out, I hope.
This is brilliant. So we go to the sizzling specific backups. That's our game of Rochambeau.
That's it, exactly. And you can just literally go there and click run, and you'll be here playing in the right hand side. And of course, feel free to mess with the code and stuff, and add end of level bosses.
Okay. Spicy. This is exciting. Well, so we are setting a serious foundation. Where do we go from here? What's
the next step? This whole thing was to give you enough foundation in programming so that as we go forward, I can kind of illustrate concepts by showing you code and by writing code together.
Okay.
In order to get from where you are after you've completed your homework to being able to start thinking about the underlying principles of how a blockchain is built and start building our own toy one, there's 2 big chunks of knowledge that I need to drop on you, and those are hashing functions and public key cryptography. So next session, we will start off by, I'll really quickly implement the homework myself, and glance at a couple of submissions that hopefully people will have done, and of course yours, Matt.
Okay.
And then we're going to get into talking about hashing functions, and the homework will be a toy miner, in fact, even though there won't really kind of be anything to mine, but all this stuff will make more sense by the end of the next session. But hashing function is episode 2.
Excited. Well, do your homework, people. Thank you, Tanner. This is brilliant.
Thank you so much, dude. And thank you, ladies and gents, for joining. We may have to do all this. We may have to repeat episode 1. It sounds like there was some messed ups with the AV
probably. I'm sorry. Yeah.
I took good notes, Tanner, so we can recreate it.
Say again.
I said I took good notes, so it'll be easy to redo.
No, it's like it will be a version 2, and it always sounds fake.
We'll keep it real.
Yeah. Yeah. Well, I like to add is it's getting warmer outside. It's getting more leisure-ish, something with the clubs at my scene, and I don't know. It's the 7th time we do this Friday night turntables, and maybe next week. It depends on the weather. I'm not here, but probably I am because I am a boring guy. No, not really.
You're the devil. Nothing boring about you. All right, people. I am out. Party hard.
It's been an
Well.
absolute privilege. I'm just going to add some final notes to the topic of our program. Other than that, peace out.
Fare thee well. Peace out.
I gotta throw you all out.